Okay, good day. Today I'm going to do Thevenin theorem. I think on my previous video I dealt with a KVL and nodal analysis. Hopefully after this video I'm going to do superposition theorem. So yeah, let's get to it. I chose this problem specifically because I solved a similar problem using KVL, I guess, mesh analysis. So you can use the steps that I'm going to use in this video to solve the previous problem of KVL, and you can also use the steps that you learned when I was teaching KVL to solve this particular problem, just to verify that you can still get correct answers. Okay, but just to make some methods clear, if your question paper says use Thevenin theorem to solve this particular problem, make sure that you use Thevenin theorem. Sometimes it's not about how you can solve the problem, it's about can you follow instructions. Okay, let's get to it. Okay, now the question says we must determine the current that passes through the 32 ohm resistor using the Thevenin theorem. Okay, so the question specifically is asking us to determine the current that passes through this resistor using the Thevenin theorem. Okay, so what is the first step of solving this question using the Thevenin theorem? Firstly, you need to remove your load resistor, of which is the resistance where the current must pass. In this specific scenario is the 32 ohm resistor. So what you need to do is to redraw this circuit without this 32 ohm resistor. So if I try to redraw the circuit, I'm going to waste a lot of time. So right now I'm just going to erase it. Okay, fine. So you have to redraw the circuit in this specific way. Okay, that is your first step. Step number one, redraw the circuit in this format. Okay, step number two, you need to remove any other sources. In this case it's our voltage source. Replace it with its internal resistance if it is given. If it is not given, just assume it doesn't have one, so you basically replace it with a short circuit. So basically you are going to avoid it and put a straight line there. Okay, so basically you assume as if this voltage source is not there. So I'm going to erase this part. Okay, let me just redraw it. Okay, so after removing the voltage source, this is our new circuit. Okay, this is our new circuit. Okay, so from here we have to calculate what it's called Thevenin, VTH. This is our focus right now. We need to calculate our Thevenin voltage. Okay, not I'm sorry. Okay, yes, we need to get Thevenin voltage, but right now I made a mistake. I'm looking for R Thevenin. So how can you minimize all these resistances into one? Okay, so the first step is to simplify the circuit. So as you can see here, point C and point D, they are connected. Okay, so you can simplify this circuit here by connecting point C and point D directly. Okay, so in your case you will need to redraw a new circuit, but it's gonna take a lot of time. You just have to draw this circuit again. So here I'm going to draw it not in a red pen or a blue one, so make sure you disregard the black one. Okay, so I'm going to draw that external line here. Okay, so right now this is our new circuit. Okay, just removing that short circuiting line and put in between C and D, we have a new circuit. So can you simplify this problem? Of course you can, because there's some interesting facts you can see. I believe you can see that resistor 2 ohm and resistor 11 ohm, they are in parallel, and resistor 14 ohm and resistor 3 ohm, they are also in parallel. But for argument's sake, let me redraw it so that people can understand what I mean they are in parallel. Okay, so I'm going to have my 2 ohm. Okay, then here we are going to have our point A. Okay, then I'm going to have my 11 ohm. Then here I have my line CD. Okay, then here I'm going to have my 14. I forgot to write the value there. I'm going to write my 14 ohm. Then I'm going to write my 3 ohm. And this is point B. Okay, so I have simplified this circuit into this. This is CD, this line is here. So 2 ohm resistor, your 2 ohm resistor is connected to point C, and it's also connected to point A. Okay, your 11 ohm resistor is connected to point A and point D. Okay, same applies to resistor 14 ohm with B and C, resistor 3 ohm with B and D. Okay, now if you look into your definitions, you can check the definition of parallel connected resistors. They share 2 common nodes. Okay, so point C is a node, D is a node, A is a node, B is a node. So resistor 2 ohm is sharing C, and it's also sharing A with resistor 11. Why am I saying that? CD is one line. Okay, so point C and point D can be taken as a common point. So let me simplify this circuit so that you can understand further what I mean by that. Okay, so this circuit is equivalent to this. I'm going to have my 2 ohm, I'm going to have my point A 11 ohm. This is my point A. Okay, this is my 2 ohm, this is my 11 ohm. Then it's like this. Okay, so since this thing is a line, you can just minimize it to be something like a point. Alright, so this line is line CD. Then we have our 14 ohm and our resistor. Then here we are going to have our point B. Okay, so I think now you can clearly see that 2 is in parallel with 11 and 14 is in parallel with 3. Okay, now if you sum all these resistances, you are going to get what we call RTH, the value that we need to put here. So how do you get that one? So these two are in parallel, but this parallel connection is in series with this parallel connection. So how do you calculate your RTH? So let me wrap. So your RTH will be equals to 1 over 2 plus 1 over 11. You reciprocate them, then you add, since they're in series, okay, you add this parallel connection. It's 1 over 14 plus 1 over 3. You do the reciprocal of that. So let me take my calculator and check 2 times 11 divided by 13 plus 3 times 14 divided by 17. Okay, I am getting my RTH as my S4, 1, 6, 3. Okay, the decimal point will depend on your question paper, of course. If they tell you that round off to the nearest whole number, then it's a 4. If they want decimals, if it's 2, if it's 3, you can round off to the nearest. Okay, fine. This is our RTH. Okay, now we need to note this value down. Alright, you need to make sure that you get this value down. Now since we have our RTH, we can look for our Thevenin. So how are we going to look for our Thevenin? I am going to go back to the initial circuit that we had, okay, when we started this video. I'm sorry, it's gonna take a while to get there. Okay. Okay, we are going to use this particular circuit here to get our Thevenin. Alright, so now we can take this point as our reference node and make it a ground, because in the question they didn't specify, and this point is 54 volts as stated by this power source. Okay, now what you can see, you are given the voltage here. Let's say we are looking for voltage VA. What will be the VA, since here it's 0? So VA will be 2 divided by 13, of which it's 2 plus 13, 2 plus 11, multiply by 54. So let me see that we have 2 over 13 times 54. I I'm getting 8.3 volts. So here I have 8.3 volts here, 8.3 volts. Okay, let me write in a different color, and I will specifically tell you why I'm looking for VA instance, why not any other voltage. I will clarify that, because you need to know why am I taking the steps that I'm taking. Okay, so here I get 8.3 volts. All right, fine. Let me go back to black. Now let us look for VB. So VB would be equals to 14 divided by 17 times 54, which is equals to 14 over 17 multiplied by 54. I am getting 44 comma 47 volts. Okay, now I want to get the resistance that passes through this point. Remember, here we have our, what do we call, our load resistance. Okay, and the voltage across that load resistance is our Thevenin voltage. So our Thevenin voltage will equals to VAB, where the final point is B, the initial point is A. So final minus the initial, we will have 44.47 minus 8.3, which will equals to minus 8.3, which is equals to 3.17, 36.17 volts. So my Thevenin is 36.17 volts. So right now I'm going to draw my Thevenin equivalent circuit. That is the final step. So and then this should be according to the theorem stated by Thevenin. Okay, so how do you draw your Thevenin equivalent circuit? So here it's gonna be my VTH, which is Thevenin, okay, of which it's 36.17 volts. Okay, then I must have my, there's a bad drawing. Okay, then I must have my Thevenin. Okay, then I must have this, of which it's my Thevenin. Not my Thevenin, but my Thevenin. What did we get for Thevenin? It was 4, something. 4.16. 4.16 ohms. Okay, now remember we removed a resistor here of 32 ohms. There was a 32 ohm resistor here initially, so it needs to come back as 32 ohm resistor. Then you must complete your circuit. Okay. Now the initial question said calculate the current that passes through the 32 ohm resistor using Thevenin theorem. So I equals to, I think it's voltage divided by current, of which Thevenin is 36.17 divide by R Thevenin. This one I should write the formula so that you guys can know what will happen here. So this should be this is the current that will pass through the load, okay? It should be VTH divided by R Thevenin plus R load, okay, which is equals to 36,17. That's my VTH divided by my R Thevenin, which is 1,16 plus 32. So the current it will be to answer 4,16 plus 32, which is equals to, I don't believe this, but okay, I get 1 amperes. And again, I can be wrong. Okay, so okay guys, you can try to use other applications to simulate the initial circuit that I gave you and measure the current that passes through that load, or use other methods to verify this value. If it is wrong, well, I will be more than happy to hear about the correct one. Okay, I hope this video will assist you in solving more other problems, and good luck with your first year course. Okay, please do not forget to like, subscribe to my channel to encourage me to create more content. Okay, cheers.